Today we're going to talk about some very basic statistical concepts. And we're going to talk about two items. One is something called a mean. You'll also hear that also called average. And then we're also going to use a term called standard deviation. Both these are very, very common statistical terms, and they're used in almost all applications of statistics in something that we're going to call a normal distribution. And by looking at this, we're going to identify something that we're going to call outliers. So on any data set, it doesn't matter what it is. It could be a group of people looking at a group of people that are aged 50 to 60, that you're trying to look at average weight and what causes people to be heavier or lighter. It could be nutrition. It could be anything that you're wanting to measure, including what we're going to talk about after this introductory piece, repair orders, and something called dwell efficiency. But the basis of this is a data set. And that data set we divide into two things. One is some sort of count, and the other is some sort of measure. And so we could be dealing with age, we could be dealing with, again, with weight, we could be dealing with anything. And when we start to sample this, we get the data reported in what's called a normal distribution. And a normal distribution is almost any set of data. It's not always normal, but it looks fairly normal. And we all know the term a bell curve. It looks something like that. And inside of that bell curve, you're going to have this green line. And that green line is the mean, or the average. And that average, again, just simply means the high and the low divided by 2, or the entire group of data divided by the number of data items that are in there. And what you will find then is that there is something, again, this standard deviation, and that means how far from the mean do different data sets lie. And so we have something, first of all, that we call the first standard deviation, and that is 68%. So that you get 68% of the data between these first standard deviations. The second standard deviation from here to here will contain 95%. The third is 99.7%. Anything on the outside of any one of these standard deviations is an outlier. And so those outliers fall in these tails. And so if we're looking at 95%, the outliers fall in this area, both good and bad. If we're looking at something that on this axis is good on this side and bad on this side, then we could discover on these outliers what makes them good and how can we apply that to all the rest of the data and learn from that. How can we adjust things? If we look at the bad that falls on this side of the axis, we can start to learn those bad things and how they might apply to the rest of the data in terms of changing it. And what we'll see over time is if we act on these two sets of data, we're going to start to see the data set, if it's the same size, start to do something like that. Our mean may not change, our weight may not change, but we get more people within this distribution that are weighing the same thing. So this is the mean, this green line. All the data divided by the number of points gives us an average. The standard deviation broken into, in this case, 3, but we can have more than 3. But we started with 68%, 95%, and the third standard deviation being 99.7. Our graph is a normally distributed set of data, and we are looking at the outliers.